Okay, so on Friday, we talked about the Pythagorean theorem. So let's just give ourselves a little reminder. In a right triangle, we have three sides. A and B are what we call the legs. They are created by wherever that 90-degree angle is. And across from the 90-degree angle is what we call our hypotenuse. Remember, the hypotenuse is the longest side, okay? And our Pythagorean theorem is a squared plus b squared equals c squared. Now remember, we can only use this when we have a right triangle, which is what I'm going to give you, okay? So here we go. In number one, let's first identify which one is the hypotenuse. Okay, x is our hypotenuse, so that's going to be like what our c is, okay? So the Pythagorean theorem is a squared plus b squared equals c squared. Okay, well, 5 and 12 are our legs. So we're going to write 5 squared plus 12 squared. This time, we don't know what c is. So we're going to write it as x squared. Okay, so now our job is to solve. Okay. So we know that 5 squared is 25. Remember, this is all without a calculator. 12 squared is 144. Okay. Now, 144 plus 25 would be 169. Okay, so this is why we did all of our work with squares and square roots. To undo a square, we are going to square root both sides. So this becomes x because a square root and a square will undo each other. And we know that the square root of 169 is 13. Let's try number 4. Okay. We have a squared plus b squared equals c squared. Okay. Well, I know that this is my hypotenuse. So I'm going to label my A, B, C. Okay. So I'm going to write 9 squared plus 12 squared equals x squared. Well, I know that 9 squared is 81 and 12 squared is 144. Okay, well, that's 225. Okay, well, to undo a square, we're going to square root both sides. So x is the square root of 225. Well, we know that the square root of 225 is 15. Okay. Okay. Now, here in number 5, notice how we know that the hypotenuse is 10. We're missing one of the sides. Okay, so I'm going to label this A, B, and C. We know our Pythagorean theorem, a squared plus b squared equals c squared. So now I'm going to write x squared plus 8 squared equals 10 squared. So we know that 8 squared is 64 and 10 squared is 100. Okay, well, now we need to get x squared by itself. So we're going to go ahead and subtract 64 from both sides. So now we have x squared equals 36. Okay. Well, now we need to undo our square. So we're going to square root both sides. Since the square root of 36 is 6, we get x equals 6. Okay. Let's go ahead and look at number 7. Okay. We've had a pretty good time having perfect squares under our square roots. What if that doesn't happen? Okay. So notice here how this is our hypotenuse. So we have A, B, and C. So A squared plus B squared equals C squared. So I'm going to write x squared plus 4 squared equals 9 squared. Well, we know that 4 squared is 16 and 8 squared is 81. Okay. Well, we need to get x squared by itself. So to undo that 16, we're going to subtract it to the other side. Remember, we are doing this without a calculator. If we take 81 minus 16, we get 65. Now, we need to undo our square. To do that, we're going to square root both sides. Now, 65 is not a perfect square. So we're just going to leave this as the square root of 65, and that's going to be our answer. Okay, how about you set up number 11, press pause, and see if we can get to the same place. Okay. So we have x squared plus 5 squared equals 7 squared. 5 squared is 25. 7 squared is 49. Okay. We need to get x squared by itself, so we're going to subtract 25. 49 minus 25 gives us 24. We now need to undo the square. "24 is not a perfect square, so our answer is going to be the square root of 24. Please do your homework, check your work, or show your work, and check your answers.